All right. Hello and welcome to today's stream, episode of the BC coding stream. I wanted to get into this topic for quite some time already, and today is the day where we're going to explore this a little bit. And today's goal is, if you want to call it that way, to really get an understanding or some sort of understanding of how AL table keys correlate with indexes on the SQL Server, and also how Business Central, how the queries you write in AL correlate to the SQL statements generated from them, and how to create keys that make your code run best. I think that's how I would define it. And first things first, I don't know when Waldo last time tried his tools, but they don't work anymore, and we need to get this fixed first. So in case you don't know it, Waldo published the BC performance tool. That's how he called it. And it's a pretty handy thing, and I think he showed this a few times on various conferences and various sessions. And when I did play around with this a little bit before, I used this and I want to use it again. And I remember that I had an issue with this before, so this was already in there, and it's in the install demo data code unit, because apparently it tries to change the value of the outer increment field, and that doesn't work. So let's see if we can get this fixed and then start to investigate this a little bit, this topic. Okay, install demo data. Where is it? This one. And job queue and queue. Wait a second. This is base app. Where's that base app? Oh, I remember. This is the problem. Yep. Okay. So one entry gets inserted here, and then he reused that one. So need to be 7, and here 8, and yeah. Okay, now that should work. Okay. Come on. Freshly created containers, sometimes they take a while to get up and running correctly. So hope it will get better in a few moments. I also wanted to see schedule job queue entry for later. What does that mean? Schedule add. And schedule add is date time What's that, 500 milliseconds or probably to run immediately, basically. Now let's see if we already have some data or if it's still running. Just some color is bad. Wasn't there just... Wait a second. Big table. Just some table. And do we have a page for that? Code unit, just some table list. And this is just some table list. Okay. This one. Okay, I'm gonna bookmark this. So what this basically gives us is 236,000 records. Still growing. I feel like 500,000 will be the end goal, but I'm not sure. So we definitely want to wait until this is done. Definitely. Yep, still going. All right. Let's grab a screenshot and tease Waldo a little bit. The tool, by the way, is open source and free to use, so check it out on GitHub. You should be able to find it on Waldo's page. Otherwise, I will put it into the description. And actually, while we are waiting, I'm always searching this stuff. Copy remote file URL. I mean, that's good enough for me. I was searching for open. All right, so this is in the YouTube chat. And again, I will put this into the description afterwards. So you can use it. I hope 500,000 will be the end of this. But we'll see. It's still running. Yeah, I mentioned this on Twitter before. It really took me a time to get everything started. I needed to reconfigure Docker to use an IP address. So I needed a different network on Docker to expose the entire Docker container on my local network so I can access all the ports with ease. And that way we can also look at the database. And that's what we need to really inspect what's going on underneath. And yeah, let me just close out those. So this is the Azure Data Studio. That's a really cool tool to do like stuff on the SQL Server directly. If you need to do that and you didn't know the tool, check it out for definitely, so you can see if that's something you can use. Yep, there we go. Okay. So we are done. All the records created. So let's check out the different tables from that extension. So there should be a test series of some kind. Yeah, I think I need to remember how to do this. Give me a second. This is, oh yeah, this is proof tool triggers on gets you data. So where does this get raised? Find all references. Find all references. Oh, so this is the page. There we go. This is the one. And it's already bookmarked. Okay, great. So this is, again, little explanation of what's going on here. This is what Waldo created basically, and we have already a keys section. And this lets you do, and I'm probably using it all wrong, but you can do stuff like you can execute those suite lines one by one, and it basically, I think it uses the performance profiling things under the hood, and it logs what happened in the background, and you can repeat this. Now it takes longer. Interesting. So the first count without key did 5 statements. Now it's down to 1 statement. I don't know. We have select latest version enabled, so I don't know what's going on. And this one with key is, you can see the first one took a little bit, but now it's faster. And if I run this one again, we're down to we're again. Oh no, this is okay. Let's have a look at this. We are significantly 16 times, almost 16 times slower with this one. But what I want to do now is I want to really look at what's going on the SQL Server level, and we will do a little bit more like different examples, and we might reuse a little bit of what's like done here just to initiate some statements. But first, we need to get the debugger hooked onto this. Let's see. And the way this works is we have, by the way, I really like the structure of the folders here. It makes it really easy to find stuff. Those kind of code units, they implement an interface and do some handling of the execution and inserting into that list. But basically, they just have some functions which do all the magic, and they get executed. And this is what happens. And if we look at that table, we can open that. We can open and close the rest out. Close others, and let me open up that again. So what's basically going on is in the keys, the first one does a set filter on 2 values on the column called color, and the other one does the same with color 2. And color 1 does not have a key because it's commented out, and the color 2 one has a key. Now, since we are looking at SQL Server, let's have a look at that table on SQL Server and find out how that looks like. I know this is not really important in cloud days, like you cannot look at the database anyways, but I like to just always have an idea or get an idea of how that looks like. So I believe we are in Kronos. I believe so. And let's look. Okay, keys on SQL Server are, I think it's called clustered keys. It's the primary key. Don't know if this gives us any information. We can do a create script. So this is a primary key clustered constraint. And this one is for the system ID. And this is a unique non-clustered key. Okay. So also a constraint, a unique constraint that you can always, that the system ID always needs to be unique. All right. And then we have indexes, and that's what on like in SQL Server language is called a secondary key. Those are primary keys. Oh, this is a primary key. This is a constraint, but those are secondary keys or just indexes, which are defining a way of grouping data, and that helps the SQL Server to access that data. 1 second, I will be right back in a minute. Okay, so secondary keys or indexes used for grouping. And if we have a look at this, this is a unique non-clustered index on, or this is the name color 2. So this correlates with the name given in on a SQL Server. So I mean, we in cloud days we cannot access, so we don't care about how it's called on the SQL Server, but it's a nice thing to know, I think, that this influences the name here. So this way we can actually really quickly find what's going on. And I think this is just a table name, and then it defines the columns that this index is created on. So what this means is, I said that those are grouping indexes, but Business Central always appends the entry number at the end. That means we get a unique index because the primary key is unique. And that basically just means that we have not grouped, but just sorted data in that index. So we can, I think there is a way to select directly from this index, but what it basically means is if we do a select, and let me just do this first, so I get IntelliSense color 2. And now I can access this, and I want to see the actual execution plan now. And by the way, when selecting, it only executes what I did select. And now we get the execution plan, because the results are really not that interesting, but you can see that all blacks are together. And then eventually we'll probably see different colors. So that's the sorting I meant. And we don't even, okay. And what this, I wanted to see the query plan. So this says that we are seeing an index scan. It uses an index scan. So I'm not an expert on SQL in general, but I mean, when it says it scanned the index, I'm pretty sure it used the index. So now let's do the same thing with the color column. You see, those are not in order anymore. And we seek a clustered index scan. So clustered index scan means primary key. It just goes through the table and reads all the data basically to give us the color. And this might not make a huge difference, I mean, we get like estimated IO costs. I cannot go with my mouse there, but you see the estimated IO costs of 6.8, and I don't know what unit this is. And a CPU cost of 0.55. Let's do color 2 again and compare. The IO cost is much lower. I'm not sure why, because we retrieve the same amount of rows and we don't really care about, like, we did not define any filters so far. So let's do where color 2 is just black maybe. And no worries, I will go back to AL in a minute. Okay, so this is again now it's not an index scan, it's an index seek, and the costs went in the 0.05 area. Now let's do again the one without the index. Now it even says that there is a missing index with a huge impact, because it did do a clustered index scan, so it needed to go through the table and filter out the ones we needed, while on the color 2 with the index, it actually just went through the index, took the first ones until there is no more black, because it knows they are sorted in order, and then yeah, exited basically. So this is what's going on here. Don't save this, go back there. Let's start the debugger finally and see what Business Central creates, what kind of statement Business Central creates there to retrieve the data from SQL Server. All right. Okay, so let's run this without key. And in the debugger side, we can look at the last executed SQL statements. And I don't know why, but the last executed is SQL number 9. So it stopped in the debugger before we executed this. So we need to step over. And now we see there is a count statement. So we can copy the value. Copy the value and open a new query and run this. So format document. Is there still something? Okay, so few things. Those are parameterized queries, so we don't get the actual values. But that's not a problem. We can just put them in there manually like this, and then we can run that query. Yeah, I don't need to save that. So let's just continue here, so it doesn't stop on the query anymore in the debugger, and let's just run this. So there's the number. It took a not measurable amount of time. And this is the without. The one without. So that's actually interesting. So let's enable the actual execution plan and see what's going on. All right. So again, it complains about a missing index in here. We get a clustered index scan, like we saw before. Then it does need to do an aggregate. It does need to do a compute scalar, And whatever that means doesn't really matter, but what I'm always looking at is the estimated IO costs and CPU costs. So those two numbers are important, and that lets you compare how fast it actually was, because we don't get even like any time measured here. And I'm not sure if there is a way, but I don't know of any to find out how long that actually took. Now let's do the same with color 2. And again, we see the index seek and then the aggregate. And estimated IO cost and CPU cost is now at 0.11. Let's copy this over and execute both so we can compare them directly. Like this. Oh, it just gives us the last one. Oh, that's annoying. So 0.11. and 6.8. So it's a lot slower. So this is a really simple example. Well, that's interesting. Didn't we look at this? Color 2, create. Oh, and it has an include for the quantity. I'm not even sure if that actually does make a difference here. Maybe not for this query, because we're just doing a count. But there's some index fields would make a difference. So let's go. The debugger is still running. We're looking at the one with the key, color 2. So let's do a breakpoint here as well. Why doesn't it register? Okay, let's try like this. Okay, there we go. Copy value. Format document. So it does the same thing. It just yeah, it's the exact same query. There is no really difference. All right, so let's enable. I don't want to save it. Let's enable that some index fields for a second here and republish. Oh. And let's grab the SQL one, and you can already see, at least I already saw that it worked, what I wanted to show. All right, so the where clause is exactly the same, so I can copy from here. But it does do something different now. We had a count star, now there is a sum. Don't know why it complains about that. And what it does, it doesn't count on the table anymore. You can see that this got added. There is a vsift whatever. And I can show you what this is. And this is in the views section. And need to scroll down or just copy the filter. That might be easier. All right, and there are a few of them. No, two. Actually, there are two of them. And ours is the color 2 one. And we can see, and we can even do a select top 1000 for those. And what you now can see is that there, because we did specify that we want to have a, how's it called, some index fields for the quantity. Could remove this, by the way, but it's all about this, some index fields for the quantity. What Business Central did was it created this so-called indexed view, as far as I know, correct me if I'm wrong. And that indexed view basically just is a view with an index on it. So it's fast for data access, and it holds data for a sum for the quantity, always also a count, and grouped by whatever fields you specified on the key. So that means we wouldn't even need the sum anymore. Oh, we need it because we are looking for 2 colors. But if we would just filter for 1 color, I could imagine that they're still doing a sum. But what all you need is you need to select that one line and read that one value from this indexed view. That way, the data access is much faster. And let's look at the query plan for this actually. So again, it does a clustered index seek because there is the index on that view, as I explained, and this is a unique clustered index by the color. And I mean, in this example, we only have 10 colors, so I'm not even sure if it's actually needed to make this faster. It might be needed since it's a view, but yeah, so it can scan that index, and look at those numbers. We saw like a 6.8, we saw a 0.1 being fast, and now we see a 0.003 in the estimated IO costs, and CPU costs even lower. So it's much faster. It's basically just reading a single value, or in this case 2 values, doing an arithmetic operation, and that's it. And what I'm working on, this is investigating how Business Central creates, like when defining keys and doing data access, how it correlates and what ends up executed and created on the SQL Server. So I'm trying to understand how that all works with like really looking into the details, what queries get created and what keys get created, what keys get used with the query plan, and like all the tools I know of. All right, so this is that. Included fields, again, it's not a sorting or grouping, but it's just like also keep the data for the quantity in that key. And that basically just means that if you access both fields, let's do like a sum quantity like this, can still do an index seek. And let me see what kind of columns we have. Is there anything else I can sum on? Not really. But when I can do like something like, I don't even need to do the sum because we're just filtering. So I can do like message. Oh wait, first this example. I still get the index seek, like working on the index. It's not a scan anymore, but it's a seek, but still index. Now if I do message instead, I get clustered index scan. So that means when you include columns into your indexes, if you select those fields alongside with your filters, then the SQL Server can still use or give you the data by only using the index. Now, let's translate this back to Business Central and see what's going on. So, in particular, those queries. How would that look like? And I will just extend this example here. Select what shall we call it? Was it amounts? Was it this? I'm so bad at remembering those things. Quantity. Select quantity with key. Okay, and the filter will stay, but we will do a find set instead. And in order to have the fields selected, we need to do a set load fields, and we'll do quantity. Breakpoint. The debugger, run the debugger. Let's see what ends up running on the SQL Server. Okay. Wait. Let's keep the first one in here just as a reference. And this is black and this is white. Now you notice that there is a lot more going on than what we created before. So first of all, we get this. And what this does is it's just an alias for the table. They wouldn't even need that. So let's actually go ahead and remove that, because again, it's not needed. It will execute just fine without it. And I really need to stop saving this. Do some more formatting here. Right. So we did what did we do? Filter on color 2, set load fields on quantity, find set. Nothing more, nothing less. We got timestamp entry number I can understand this. This is the primary key. This is the column we selected. This is the column we filtered on. I mean, I just want to filter on it. I don't want to read data from it. I mean, I don't care. I just care about the filters. System ID, and then the created add and by fields. Created, modified, add by. Let's run this. See what happens. Clustered index scan. Doesn't care about the key at all. But I mean, we did create a key for exactly this scenario, didn't we? There is the color 2 included fields quantity. Let's remove the sum index again, because just to reduce confusion. Color 2 included quantity. But Business Central doesn't more. So again, we need to think about that this color 2 one, it has the entry number in there as well by default. So we do not need to care about this. But what about the other fields? I don't need to save this. Okay. Let's remove this, just to make it more simple. And let's just be sure that it's still doing its thing. Now it's already starting to complain about that there might be a missing index. And you can see already what it does. Color 2, and it should include timestamp, quantity, system ID, system created add, created by, modified add, and modified by. So let's do that. Included fields. So what again, I'm really bad at remembering stuff. The system fields, basically. Let's add those. System ID, system created add, modified add, system created by, modified by. Now it did also say we should include the timestamp. But AL does not give us access to the timestamp column at all. So there is no way to add that. Let's just publish this for a second. And then see if we can make this query actually use the key we created. There is a gotcha to this, and I will cover this in a second. Actually, there are many gotchas, but let's cover them one by one at a time. Let's start the debugger. I did not. Okay, but doesn't matter, we have the query in here. So let's run it again. Clustered index scan. It's still complaining about the timestamp. Now what if we remove this? Just not select it for just a second. And there we go, index seek. We did not look at the numbers. How much faster does it get? 6.8 I/O cost, 0.55 CPU cost. Let's remove it again. This could be a drinking game with my saving. So, and now index seek, we had 6.8 at the I/O cost, now it's 0.35. So it's so much faster if SQL Server can just rely on the index and read from there and just not care about the base table. Because you need to, like an index, you need to think of as a copy. It also has some space consumption, and we can look at this actually within Business Central. How is it called? Data administration. Yeah, let's refresh this and look at it. Because it's physical space usage on the drive. Just some table. Now this is not the one. It's a table information. The one is, yeah, this one. Right, so this is the size, and oh, we actually, it created in every company. That's stupid. Sorry. And what you can see is we have a total size, and we have data size and an index size. And you can already see this is 92 megabytes and this is 74 megabytes. So the size on disk used by indexes already more than the data size. So it really, the SQL Server can select data right from that copy of the table to do those kind of queries. Now, does it even make sense then to create indexes at all, like keys on tables, if the SQL Server doesn't use them anyways? Well, it's not that easy. Thing is, if queries get more complex, let me see if I can, if we can force it to something more complex. What if we do like this? I hope the placeholder, wildcard placeholder, was a percentage here. Index seek. What if we remove those? Message 2. Still doesn't. The filters are not complex enough. Let's see what other keys do we have. We do not have composed keys. So I'm not sure if I will. I don't want to try and try to find something. But basically, if the filters and or sorting, let's give that a try. Order by color. Descending. Yeah. So this is what I wanted to see. Nice. Okay. Happy that I got that working. Okay. So it does not, because of the message 2, we do not have a covering index, meaning the index does not cover the entire query we have. But still, the SQL Server decided that finding out and finding the correct data in the right order we want to see here is easier by using the index, although it doesn't contain all the information it needs, and then later joining this again back to the table to retrieve the messages from those rows. And I hope this isn't too complicated now. So it uses the index to find the correct data and then uses the table to display all the data we need. And in those kind of examples, it's still better if you have an index versus not having an index at all. So if I now do this, use the non-indexed color column instead, it will just do a clustered index scan because there is no index, and then we have Like the lookup again, 6.86, and then the sort is actually 377. So that's really slow. And we get it 1 second actually. Let's go back to color 2 and compare. So that's instant. We do not even have a sort in here. And here we have 0.003 and 1.7. So in overall, this is again much faster than the alternative without the key. So there is a benefit, but it's really hard to tell at what point that benefit kicks in without actually analyzing the query execution plan. Let's see if we can find something more. So you see, if I remove the wildcard filters, it again decides, well, the clustered index scan is just faster. Then because the merging and the joining and everything and putting it back together still has an overhead you need to consider. So you cannot force the SQL Server to use an index, at least not from an AL. It will always decide by itself. Okay, yeah, I had a typo there. That was the reason why. So it's still using the index instead when I start to order by. Now does the order of the ordering? No, okay. So maybe a rule of thumb here would be that if you start to sort the data in any way, it will rather use the index instead. So if you do not sort, you do not need the index. If you just filter by something, probably at one point, and especially when the filters are more complex, it will then still rather have and rather use the index. Let's see if we can put some more columns into that filtering. Yeah, that doesn't work. Nope. So let's use the let's do this. And country is either KZ or country is CD, whatever. Let's remove the filter. Let's run it like this. It's still okay. That's interesting. So we don't have a covering index here at all. It still does the index seek. Does it tell me? Doesn't tell me which one. But it does somehow, but I cannot see it. Okay, so it does the index seek, then it does another index seek. Because we have this. Because we have two different indexes to do the filtering. Then it does a hash match, key lookup, and then puts it all together to give us the final result. So even two different keys can be beneficial. I can improve the outcome. That's interesting. So you don't even need to have one key to cover it, to cover the entire query. It helps to have two separate keys on the table, and then it will still improve the query performance. And it's rather quick. It's still rather quick. Let's see how bad it gets when we remove those. Sorry. That's one thing about living on the countryside. There are just big machines rolling by sometimes. All right. So now we have nothing, no keys at all. And we get, again, the 6.86. That's probably due to the size of the table, the 500,000 records. So that's just what happens. But let's see. And we won't have a covering index because the timestamp column is there. But it still also doesn't complain about a missing key yet. So normally, let's do this and then do country descending. On both columns, still doesn't complain. Warnings. The query memory grant detected excessive grant which may impact the reliability. So I don't know what that means. The sort is also not really expensive here. Maybe just because we don't get a lot of data back. But again, SQL Server does not complain about a missing index just yet. So it's still okay, but that also might be due to the fact that we just have 500,000 records here. And they're not as random as real data might get. Let's put them back in. Let's look at some more complex, if we can find some more complex filtering going on here. It's just without any filters. Bulk inserts, tree state locking. Let's do. Those are rec graphs. Demos. Oh, that's okay. That's interesting. Find minus versus find set. Didn't even remember those from the presentation, to be honest. Oh yes, I do. There are more like SQL statements or something. The initial one is faster, and then you just it executes more time. Okay, not important. Not part of what we're doing here. So we do not really have complex queries here. So let's construct one. demo keys. Okay, so we have that filter. Let's have a look at what data we have. Just some list. I would expect those to be pretty random, so I don't want to do like this. But we can do filters on the quantity. Set filter quantity greater than 100. Yeah, and it already complains that there is no key. But let's see how bad it actually gets. And let's do actually this and this. And we do, so that's actually a set range, but we'll still stick with the set filter, like 800. So we actually get data. So that's quantity. Now, oh, the page does not contain all the fields, it just contains them once. And country starts with B. B star. I don't trust this. Sometimes there are some weird behaviors and I don't really remember right now how that was, so I'll just put it like this. We do not, let's just not do a set load fields now and run. Let's see what kind of queries we get there. And keys, complex select. Do some multi-cursor fun. I don't want to save this. Okay. Now we need to 100, 800. Color is black, white. Black, white. in country like B star or B%. Run. Clustered index scan. So AL complained there is no key for quantity. Let's fix that. We do not have a key for quantity. So let's just add one. We do not need compose keys, I assume. So quantity. And we don't want to sum index fields. We just want the key as it is. So let's push this. By the way, did the warning go away? Yeah, now the code cub is happy. We have a key for this, for this, for this. So let's see. Run. Still clustered in Xscan. So what if we do, like I said, load fields. Okay, let's say we don't need all the fields. We just need a message. And we learned that means we get timestamp entry number. We do not get those. The rest still stays. Clustered index scan. Let's change the order by, and for that I will again go in here and change the AL code. I'm curious how that will work. So we would do set descending on. Let's first do quantity. And we will say false to have it descending. Need to wait for it to start up because I want to use the debugger to get the new SQL query. I'm not sure what just happened. Cannot call set ascending of the field quantity because it's not part of the current sorting. That's actually something for the linter cub, I think. Okay, so that was probably because we did not do set current key quantity. Which basically, by the way, does not need to be a key. We can do message. Message is not a key. So that just, so that is the order by, and that's just ascending or descending. So I learned that. Try again. The where clause stayed the same. I'll just copy this to make my life easier. Now it's been saved. Okay, so order by quantity descending as we specified, but still entry number ascending. But again, this is the primary key, should be an issue. Let's see what the SQL Server does with this. Index scan. And the sort, actually not that. It's CPU cost. So I wonder if we didn't do quantity but message instead. Still, okay, doesn't change anything. Now what if we had... Wait a second. Wait a second. That load fields message. Oh yeah, and we still have all the filter columns included and selected as well. That's so stupid. Let's tweak this a little bit more. And I will again use the compiler, the debugger to find out exactly. Let's do the example we did before to force it to actually do use the index, or hopefully use the index. Use more wildcards. Color was like, I think like this, and color 2 was like this, and country is the same. Still clustered index scan. So I'm not sure if I will be able to force it to use the indexes instead. No. So 3 indexes might be too much. What? I mean, now, you know, we could have the idea to create one index to cover them all. Color 2, quantity and country. color to quantity country. And because we know what we're doing, we include the message. So that would be exactly what we did here. Color to quantity country include message. We filter. Let's see. And the query, by the way, didn't change. I just created the key. There we are. The combined one is here. So let's see if that does any difference whatsoever. It does not. Still the clustered index scan. Now let's remove again everything that gets added automatically by the SQL Server, because that should in theory be a covering index now. And there we go, index scan. 2.9 IO still. But we can compare with the clustered index scan. That's a 6.8. It's still the same as before. So I think the SQL Server does not complain yet that there would be a missing index, because yeah, it's not that much of an improvement. It's twice as fast. I mean, still, but that way we have a covering index. But I'm still not sure what the consequence from this is. It seems like sometimes it's okay to have two separate indexes, and then it can use both of them, like in combination, and be still pretty performant. Sometimes it doesn't work. Probably the SQL Server here decided that it's not worth using the individual indexes. And now just at the end with the covering index, we got the SQL Server to use that one because it's just an obvious thing to do. But the improvement is just not there. Not that significant to yeah, for the optimizer to do that. So I think it only really makes sense to create indexes for stuff if you either immediately notice a difference, like if you can notice a difference with the tools we have in AL, like the performance toolkit or like similar stuff with tests, for example. Or if the SQL Server already complains that there is a missing index. Otherwise, the SQL Server might not even use the index you created, because we can never create a covering index in AL because of the timestamp column. Okay, now why don't we create all the indexes we can possibly to on all of the tables, and then everything will be fast, right? So let's see if we have something that insert records here or modifies. We have bulk inserts, that might work. On modify all, nested locking, partial records read insert, and set true locking behavior. So let's look at those inserts first in code and then see if we can use that. Insert. Bulk insert. Okay, let's do something different then. I'm not happy with those tests. Let's do a modify test. And what we'll do is just one simple line of code. No, we will destroy everything. So it won't be a simple line of code. All right. This is the test. Let's remove this one. Yeah, that will be the baseline. We are modifying every record, adding 1 to the quantity. Let's see how long that takes. I'm not sure if that was a good idea, but I want to get some measurable differences without adding too many keys. Let's actually, where was it? Clear everything. Let's see. That should be 500,000 SQL statements. 1 for every row, plus the find set, so 500,001. Yeah, that was a bad idea. Maybe we want to filter it down a little bit. On the primary key, just do like 10,000 records maybe. Records. Might be quite a bit faster. Now we can actually do plus equal 1. That's easier. Okay, let's publish this to interrupt the session, hopefully. And then give it another shot. Yeah. Oh. No, it interrupted. Okay. We didn't get anything. So let's try to publish again. Do I have... I hope I don't have... No, I don't have. I thought I might have set the launch JSON to recreate. So every time I publish, it dumps everything and reinserts the data. But it doesn't seem to do that. So that was quicker. And we get 20,001 row read and a little bit over 10,000 SQL statements. All right, so let's do it one more time just to see if the 6 seconds are consistent. Seems so. Even a little slower. Now, just for the baseline, and I'm not sure if that actually makes a difference, so what if we didn't have any keys at all? All indexes are gone. You can see we already gained almost 2 seconds just because there are no keys on the table anymore. And that might be because we have those as included fields here, some index fields. So quantity is actually used in some of them, right? So that makes sense to me. Let's add another key called quantity. Just like that. That's one key on that one column, and that column we are updating. You already can see the difference. It's obviously not as much. But we had 6 seconds, 300 milliseconds, and without any keys, it was 4 seconds, 550. And now we are at 4 seconds, almost 5 seconds. So half a second on top of that. Just because, and we're just modifying 10,000 records, by the way. Just because of the one key we added. Now there is a trick, something you can do if you do heavy update operations. And I never used this, so I need to search for a second, and otherwise I will. Let me Google that. Give me just a second. Oh, there. Okay, found it. This is the one I searched. AlterKey. Oh, it's on-premise and cannot be used for cloud development. Never mind. That might become available at some point in the future. I remember something that they said it's just on-premise for now. So let's still try it. Let's switch the scope to on-prem. And let's do key ref. Table key module. There is a table key code unit. Disable all for table number. Oh. And then we obviously want to enable all, and we want to measure if this is faster. What this does is, it's because, okay, let me explain. When we modify a column on the base table, I explained that any index, any key you create is a copy of the data in the base table, a physical copy on the disk. So whenever you change anything, any value that's copied into one or more indexes, those indexes need to be updated as well. So SQL Server within the same transaction, like real time, keeps those indexes in sync with the data in the base table. Now what we do is we say disable all the keys. Like do not care about keys right now. And then re-enable them afterwards. And let's actually do more than one test. Let's do one disable all and one disable quantity. If I could type. And that would be without the code unit, without the overhead, just with Database.AlterKey. Where does it get? Oh, that's the record key. Maybe we can use, there's all to all. Okay. Let's see. This needs a key ref. Let's do regref. Regref. Open. I would say it's either 1 or 2. Let's give it a shot. Normally you should do this differently, of course. But (13 or greater). Wait a second. Okay, that's way off topic, but I just realized I had runtime version 11 called, but had a dependency on the system app. The system app has runtime version 13, and I can, so that means I can have dependencies on higher runtimes using features I have not enabled on my end, but using them based like by calling functions to them. That's crazy. I need to explore on that at some point. So let's see if that does the correct thing. Pretend extension, go away. Let's do it this way. Just so I can find out if I'm using the right key here. Yep, okay. So that works. Now we can do the comparison between the both of them. And of course with the base test. Okay, so this test, I cannot delete those. Okay, so this was the message. So let's do this one again. What's going on? Oh, the modify test does not exist anymore. Let's fix that. I want to have it all in the same session, so. Okay, so 4 seconds, 800. With that one key enabled. 4 seconds, 700. Now let's with it disable all. Nothing. Try that again. Nope. So something's broken there. I don't know what it is. Let's see if this one does work. No. Why though? I have no idea. So that doesn't work. So basically the takeaway, what I wanted to show is with lots and lots of keys on the table, if you just do, I mean, I don't think I can do this. Yeah, they have the identical list. So what happens if I do this? Does it let me do that? No, it doesn't compile. Okay, so I can't have the identical list of fields, but I can do like one with message. And then I can do one with country, one with country 2, one with country 3, and that's nonsense, really. Color. Color 2. Message. And message 2. Let's renumber those. Let's see how bad it can get. Oh, we had message already. So let's do whatever they created. And let's also do like some index fields quantity. Does that work? That works. That's actually ridiculous. And I mean, at the very beginning, we saw that even if I have a quantity field and have this specified as some index fields in all different kinds of keys, it still affects performance drastically. And that's really the thing. And you can already see by publishing, and now the SQL Server creates copies and creates those indexes in the background. Oh, there we go. Faster reading comes at a cost of slower writing. That's always the case, and any database developer will confirm that to you, that you shouldn't go too hard on the indexes, because you might do faster reading, but you will definitely do slower writing. And that really in the end depends on the use case, on the scenario you have. If you do not do modifying of the data too much, like changelog, for example, you do not modify the changelog anymore, or ledger entries. You just read them and you add new records at the bottom. So in that case, you might be good with having a little more of those indexes or keys than on something like the sales lines. But in the end, you need to test this, and you need to know a little bit what you're doing. But hey, that's why we're here. That's why we're looking at this. And now we are up to 20 seconds just by adding a bunch of keys for the same stuff that without keys just takes 4 seconds. And I think I will wrap up for today. That's what I wanted to go through a little bit. My goal was to give you a rule of thumb, and that I might need to do some more investigation and try to get that goal next time. But in the end, just to summarize a little bit, we cannot do covering indexes because of the timestamp, and that if anyone from Microsoft sees this, reconsider, please, with the timestamp. Covering indexes would be nice if we really need to do really fast reading. Otherwise, depending on how complex your filter is or how simple, you might not even need an index, or just if it gets, like, if it crosses a certain complexity, or if the data is like huge, you might end up needing this. And you can really either, as I explained this before, either if you already during development can prove that adding an index increases the performance, that's fine. Otherwise, if the SQL Server will scream at you in the missing indexes, and you should be monitoring those, then think about adding a key for this. Otherwise, I would consider to not add a key for a query, certainly not for everything, as we saw at the end, adding lots and lots of keys can decrease the performance drastically. And this is performance of writing data back to that table, since the SQL Server needs to keep all of those indexes in sync with the base table, and that really adds up some stuff. And also the last thing, table information. Now we have 109 megs of megabytes of data size and almost 200 megabytes of index size. So you will blow up your database size by adding, or of your customers, by adding lots and lots of indexes with lots and lots of columns. Since the SQL Server will keep a physical copy of that data for each and every index you create. All right. Let's call it a day, call it a session, and I guess I'll see you next time. If you didn't do so already, please subscribe, or subscribe if you want to get notified, basically. On YouTube, then you won't miss a stream anymore. I try to stream whatever I can stream, explaining my way along through the coding. So anytime I have something, I'm coding on something I can stream, I can share with you, I will, as much as I can. So, and as a nature of this, I cannot really announce those streams too far ahead, because I don't always know what I will be doing. So those are pretty spontaneously. So subscribing will be a good way to get notified if the stream starts. And yeah, otherwise, have a good rest of your day, wherever you are, and a nice weekend. See you next time.